Hello and welcome to an introduction to integration. So, if you've already done, you need to have done differentiation before you can have a look at integration. I'll just run through an example. So, y equals 3x to the 3 plus 2x squared plus 2x plus 1. So the differential of this, dy by dx, is equal to 9x squared plus 4x plus 2. Now, what we need to be able to do sometimes is go from this function here back to this, which is essentially what integration does. It makes you go in the opposite step, and it's used, in fact. So if I draw a graph here, and we have this function, it gives you the area underneath the curve. So this area here, if it's a definite integral. Now, if we look at this, our differential, trying to get back to our original one, what we need to do, and I won't go through the original proof of this as it's not required for the course, but it's increase this power by 1 and then divide by the new power. So we say that the integral, which is the integration sign, indefinite because there are no limits placed, and I'll talk about that later, of 9x squared plus 4x plus 2 dx, and this shows that we're doing it with respect to the x value. So if we increase the value of power by 1 and then divide by the new power, we get 9x cubed divided by 3 plus 4x squared divided by 2 plus 2x, we've increased the imaginary power by 1 to 1 and then divided by it, plus, because there could be a value on the end, c, and we happen to know in this case that the value is 1, but due to the fact that it's lost during differentiation, we don't know what it could have been. So that is the integral, which gives us back to our original answer of 3x cubed plus 2x squared plus 2x plus an imaginary value of c. We say y equals this. So in the exam they'll probably give you, when y equals this, x equals this, what is c, or when the turning point, where it's crossing the x-axis, you know that x is 0, and therefore you can find your y value. Now, what we need to now do is an integral by a definite integration with limits. This is saying that if I draw a curve here, it's between these 2 points of, say, 2 and 4. Now I'm going to say this is an x squared graph for simplicity. So I say that we're integrating x squared with respect to x between the limits 4 and 2. Now, we do the same as before, but this time we have big square brackets around it, and we get x to the 3 divided by 3. If we were to differentiate that, we'd reduce the power to 2, or times by the original power, which makes it 3x cubed over 3, and then reduce it to the power to 2, which gives us 3x squared over 3. The 3's cancel, you get x squared. So this is in the square bracket between the limits 4 and 2. Now to work out the area for this, simply, if we were to plug in the 4, it would give you the area between 4 and 0 here. And then, when we do the value of 2, it will give us the area of between 2 and 0. So if we want to find this area here, simple geometry, this whole area minus this area here. So what we do is substitute x into the equation, 4 cubed over 3 minus 2 cubed over 3. And this will give us a final answer, which I'll just run through now. 4 4 is 16, 16 times 4. My mental math isn't up to scratch. And 2 cubed is 8 over 3. 16 times 4, 40, 6 times 4, 6, 12, 18, 24. So it's 64 over 3 minus 8 over 3. This gives us our area between the two lines underneath the curve. Thank you.